Alright, thanks for watching, and in the next series of videos we want to prove a certain number of limit laws starting with the addition rule. Namely, fact, suppose our sequence Sn converges to S and another sequence Tn converges to T. Then the question is, what does Sn plus Tn converge to? Well, hopefully S plus T. So in other words, the limit of Sn plus Tn, it's the same thing as the limit of Sn plus the limit of Tn. And let's prove it. It's very classical and beautiful. So proof. Let epsilon be given. And what we want to do, we want to find n such that if n is bigger than n, then we have that the difference between Sn plus Tn and S plus T, it's less than epsilon. Then Sn plus Tn minus S plus T is less than epsilon. So remember, in the end, we want to get epsilon. Once we see epsilon, we can stay home happy. So now let's look at this difference. So Sn plus Tn minus S plus T, so if you want minus S minus T, equals to, so let's put the S terms together and then the T terms together. And then what we can do, we can use a triangle inequality. Less than or equal to Sn minus S plus Tn. I mean, didn't I tell you that we'll use the triangle inequality very often? This is why we do it. But now, remember, we do know that Sn converges to S and Tn converges to T. So basically, we know that this is small and this is small, which will imply that this will be small. So, because limit n goes to infinity, Sn equals S, we know that there is, well, usually we write capital N, but now we just want, just not to write capital N 3 times, and to emphasize those are not always the same constants. We know there's N1 such that if N is bigger than N1, then the difference, so not less than epsilon, because we want to get epsilon at the end. We can do even better than that. We can say this is less than epsilon over 2. You see, because it is true for every possible arbitrary number. So in particular, it is true for epsilon over 2. And similarly for Tn. And because the limit as n goes to infinity of Tn equals T, there is N2 such that if n is bigger than N2, then Tn minus T, TNT, sorry, Tn minus T, it's less than epsilon over 2. Didn't realize that until now. But here's the thing. In particular, if you choose n to be the larger one of n1 and n2, both of those things happen. So let n, again remember we needed to find this, to be the maximum of those two numbers. Then, if n is bigger than capital N, then what do we have? Well, remember we had Sn plus Tn minus the stuff that we want. Again, if we repeat the whole thing, we have that this is less than Sn minus S plus Tn minus T. But we know that this is less than epsilon over 2 by the stuff I erased. And we also know this is less than epsilon over 2 by this. And now look at the beautiful thing. Epsilon over 2 plus epsilon over 2 is just epsilon. Ta-da! And therefore we're done. We have that Sn plus Tn goes to S plus T. All right, thank you very much.